Now, let's bring everything together with symmetry. A symmetry is a rigid motion of the plane in which the object and its image coincide. That means after the transformation, the image lands exactly on top of the original. So symmetry is not just any motion. It's a motion that makes the figure match itself. The two most well-known kinds of symmetry are reflection symmetry and rotation symmetry. Let's begin with reflection symmetry. A figure has reflection symmetry if it can be cut by a line of reflection in two parts that are mirror images of each other. For this, I can think of something like a butterfly. If the left and the right wings match, we can put a vertical line down the center. It's not quite the center, but that's okay. But it does give us two mirror image halves. That means the butterfly has reflection symmetry. Now, let's talk about rotation symmetry. A figure has rotation symmetry if it can be rotated around a center point through a certain angle and the image coincides with the original. A familiar example is the recycling symbol that we see here. It has rotational symmetry of 120 degrees, 240 degrees, and 360 degrees. Each of these rotations bring the figure back on itself. Now, let's find some symmetries of some capital letters. We will assume standard block capital letters. Let's start with the letter A. This one has a reflection symmetry. I can draw a vertical line down the middle. So I'll write reflection underneath this, and the letter A does not have any rotational symmetry. The capital letter B in most block fonts has no reflection symmetry and no rotational symmetry. Some stylized fonts may behave differently and give it a horizontal reflection, but B typically has no symmetry since the top kind of bump tends to be smaller than the bottom bump. Let's look at the letter H. This one has a symmetry across a horizontal line through here, as well as symmetry through a vertical line here. So it actually has two different types of reflection symmetry. In addition, it also has rotational symmetry. At 180 degrees, if I turn this thing 180 degrees, it's still the same. So H has several symmetries, two different reflections and a rotational. The capital letter J usually has no reflection symmetry or no rotational symmetry. Finally, my letter Z does have a rotational symmetry of 180 degrees, but no reflection symmetry. This is a great activity for students because it encourages careful visual reasoning. It also shows that symmetry depends on the exact form of a figure. Finally, let's mention translation symmetry. A figure has translation symmetry if sliding it in some direction makes it coincide with itself. But here's the key idea. Only repeating infinite patterns have translation symmetry. Each of these three patterns we see here, if they were to go on indefinitely, if we could draw these infinitely large, they would have translation symmetry. A single isolated shape does not have translation symmetry because once you slide it, it no longer lands on itself. But something like wallpaper, a tiling pattern, or an infinite border design can have translation symmetry. This is an important distinction, and students often find it surprising. Symmetry is a beautiful way to connect transformations to patterns, art, letters, and the world around us. As future elementary teachers, this is a topic full of opportunities for discussion, sorting, drawing, and hands-on exploration. A powerful question to ask students is, what motion would make this figure match itself? That question ties symmetry directly to transformations. You have now worked through translations, rotations, reflections, rigid motions, and symmetry. That is a lot of rich geometry thinking, and you are building exactly the kind of understanding that will help you explain these ideas clearly to your future students. Take your time with these ideas. Visual mathematics grows through noticing, sketching, testing, and talking. That is real learning, and you're absolutely capable of it.